Alright, welcome back. In this video we're going to go over the question that involves us to shade, but this time around we're going to look at a different form where we have got a different setup for our Venn diagram. In this case you can see that C is a subset of what? Is a subset of B. Okay, so now we are going to shade the given sets there. So if you look at the first part, it is requiring us to shade the region A intersection B. So what is our A intersection B? We're just trying to look at the region that is part of both A and B. So what is the common region there? So if you look at region B, basically your region B is basically this part, or this part going this side is part of B. Then if you look at the region that is part of our A, it's basically this part. So now this region in between is basically their intersection. So if you are to shade their intersection, that is what you get to shade. Okay, moving to the next question. It is requiring us to shade A intersection B union C. Alright, so how do you get to do that? How do you get to shade A intersection B union C? So as usual, we need to look at what's in the brackets first of all. Let me copy what we have. What we have is we have A being intersected with B union what? Union C. Okay, so if you look at what's in the brackets, we have B union C. So let's start by shading that part. So I'll use one color for that. B union C, I'll use the same color that I'm using now. So for our B union C, it requires us to combine B with C completely, not just their intersection but the entire region of B combined with C. So if you look at what we have, the setup that we have, you are going to see basically that your C is basically part of B. So if you say B union C, it is the same as saying what? It's the same as you're looking at what? In this case, it's the same as you're looking at B. Because if you look at B union C, it requires you to combine B with C. But if you just look at B itself, it's already going to combine C. So B union C in this case is the same as what? B. So in short, all we are trying to look at is A intersection what? A intersection B, which is just going to take us back to what we had shaded area, this region. Okay, so this is a common region, so that remains our answer. So basically the first one and the second one are basically one and the same because of the fact that our C is a subset of what? Of B. Okay, let's try to move on. So if we move to, we can move to the third one. So our third one is basically C minus that. So C minus A intersection B requires us to exclude A intersection B from the region that is part of C. Okay, so we are in C, we're interested more in C, but we're excluding the intersection of A and B. So if you look at the intersection, what did we say about the intersection? We say the intersection of A and B is this region. So now we are not interested in that region. We're supposed to exclude it from C. We need to remove it from C. Meaning that what we're going to remain with is this part that I'm shading what? In red. So what becomes our solution? The part that I've shaded in red is what we are required to shade. Okay, so we're excluding that part there. So this is what we have. Okay, so there's a part of C that we've not shaded. That part of C, which is part of the intersection of A and B, we've not shaded it. So that's how you get to answer the third part of the question. It's very, very, very simple to solve. Okay, so what about if you say B minus C? What are you expected to do? If you say B minus C, so B minus C, basically I'll draw back our C. So we have our C inside there. When you say B minus C, you're interested in the region that is part of B, excluding what? Excluding C. So B without C. So it's basically the region that is what? The region in B without what? C. So remember the C is the smaller set inside B. So the outer region excluding the C, remember our C is basically what we have inside there. So outside that, within B is what we use our B minus C. B minus C means B without what? Without C. Okay. Let's try to move on. So if you look at the next question requires us to find A intersection B intersection C complement there. So remember I said A, when you have a complement, when you have B intersection C complement, it's the same as B minus C. So we have a complement outside there. So remember for our setup, what we have is we have our A, then we have our B, then we have our C inside there. So this is our A, this is our B, and this is our C. So now we're interested first of all to find the intersection of B minus C. A intersected with B minus C complement. So start with what is in the brackets. So what is your B minus C? B minus C is the region of B without C, which we are from saying it's basically this region within B excluding C. That is B minus C. Now we are not interested in that region because of what? Because of the complement. So we are interested in the region outside that. So if you are to shade the region outside what we've shaded, your result is basically going to be what? So it would require you to shade C itself. C is going to be shaded, then also the region outside. Okay, that's what it means when you say complement. B minus C was just the region inside there. Now this region was B minus C. So its complement would require you to shade the region outside it. And that's what this is what we are adding. So now, what are we going to do? So we need to find its intersection with A. So if you try to shade your A, what are you going to have? So your A is basically this region. It's this region. Okay. So what are you going to have as a result? So in short, in summary, what we're saying is where we have both colors is what is our intersection. So this region together with that region there. So that is what is going to make up our shading. So if you get to shade that, you have your A, you have your B, then you also have your what? You have your C there. Okay, so not basically that this kind of drawing that I've done. Let me just try to draw it again. So we have our A, then we have our B, then our C is inside there. So the region that we shaded, if you're able to remember, is basically this region and also that region. That is what is making up that set. So this is our A, our B, and our C. So that is what you're supposed to shade for this part of the question. Finally, let's try to look at the last one, which is basically A complement. So remember that is our A, this is our B, and what we have inside is a C there. So we have A complement intersection B minus C. That's what we have. So now B minus C, we understand it's a region of B without C. So that requires you to shade the region outside what? Outside C, but within B. Okay, that is our B minus C. B without C. You look at B, then you exclude C. So that's what we have shaded there. Then we need to intersect it with A complement. So A complement requires you to shade the region outside what? It requires you to shade the region outside A. So if you shade the region outside A, remember this is where your A is passing. So outside that, this is what you're going to shade. So now we are looking at the intersection. Where do we have both colors? What do you get to look at? So basically, ultimately what you have as our solution That is our A, our B, then our C. So if you look at this as your A, B, and C, the region that is basically shaded is just the C, the inner C without A. So it's this part, the inner part of B. C is not part of a shaded region, and this part is also not part. So this part is also excluded because we only have green there, we don't have yellow. So basically it's only this region, and that's basically what we've shaded. C is not part of a shading. Remember, that is our C. So the shaded region is basically the solution to our final question there. So that's it for this video. Thank you very much for taking time to